All right, hello everybody. If you've never been in a Sector67 before, welcome. We do these monthly meetings like a show and tell people that talk about projects and things to work on. George's friend wrote us a donation and wrote a very nice letter with her. George Hartman was primarily in the machine shop, but he was a member for many years working on all sorts of crazy stuff. So thought I would post this up for him. Without further ado, I'm going to hand it over to Alec, who's going to talk about figuring out how Fusion 360 works. So, oh my gosh, transitions and everything.
Oh, transitions?
We can tell you're so.
Oh, this is I'll let you do the honors.
Is
there a microphone?
What's that?
The microphone?
It's to the internet.
Okay.
Yeah, you see that.
Sounds good. Okay. So you just left right on the keyboard?
Right, yeah, right there.
Oh, no, I didn't know there were transitions. I didn't actually like read this.
Well, now you're in trouble.
Okay. Well, the goal, as it says, was engraving a custom wax seal. Specifically, this is for my girlfriend because I didn't have any other ideas for her birthday. I was like, what can I do that's cool that I can make myself? And she likes wax seals. So I was like, oh, it can't be that hard. Just, engrave it. There's plenty of tools here to do it. So I set out about doing it. Yeah, this is the goal, as I just said. So I wanted to do it with her name on it. So like her name is in Chinese calligraphy, it would work really well on that because she's Chinese. So I was like, oh, I'll get someone to do the design. So this is how I started. The first step of engraving something is to choose the correct tooling and generate tool paths. You also need to generate DXFs from the design, which is just basically like a vector of the outline. And then passing that over to VCarve, which is what I use to generate the tool path, you can make the machines move around and actually cut it out with tools. So that is not how I actually did it. The actual sequence of events is I had around a week to design it and make it. So I didn't really think about like, okay, this is like the tools I need beforehand. What I did is I actually asked Chris, I was like, hey, what are the best tools to use for cutting out something small? And Chris is like, well, what are you doing? Like for the engraving. And so I had to actually come up with a design that was on the slide. And I didn't have this when I asked him about this. So the tools are just really tiny. I should have brought some with me or put a photo up in there, but they're super tiny little like carving tip. And we put it in a CNC mill and engrave out the design with it. But I didn't have it, and I didn't have the design yet. So I had to buy the tooling. So I bought tooling that was like 0.25 diameter, I think at the end, 0.5 millimeter diameter. So I bought that, and then it came, and we had like two different methods for actually making the thing. And one was using the fiber laser, which is basically like you have a laser head that will stand back and forth really quickly and cut out a pocket where the material is, so it'll burn away wherever you want it to. Or you take a bit and you spin it really fast and you go through the brass and actually carve it out. I did both, but it turned out because the features are so small. I think it's on the next slide. There we go. Okay, this is what I was just talking about. I'm really good at slides. This is actually the process for it. So engraving it was creating a DXF from the 2D design. You need to start with like an SVG or something, or you can use a tool that Adobe has a free one online. You can give it just a picture, and it'll go through and it'll find the outline of it, and then you can make that black and white, and then you have a DXF, which is just a vector file, which is a mathematical definition of it that the software can actually take and generate a tool path from. So VCarve is the software in the wood shop on the computer in there, and that ended up being what I used. Fusion 360 has an engraving function, but it does not work very well. As I found out, it would take like 10 hours or something to cut it because it wanted to go into the bottom of the top and go back and forth over and over again. So VCarve solves it better. And then there's a little mini chuck that I clamped it into, which is like a lathe chuck. There's an actual video that we'll see all this in a second. So it's not just text. The little mini chuck, I mounted it in there. Maybe I should just go into the video. Video will make more sense. This is the actual engraving process. You can see the V-tip here, the stamp end here, and then the chuck that I had it mounted in. So this is sped up about 75 times. I think it was around 40 minutes to cut this one out. So hopefully it plays. There we go. So it's going around and cutting the different pockets out. thing as according to the design. Now the problem with this one, this was not the final one I gave to her because I forgot to export a couple of features, and also, like I mentioned earlier, I didn't check my design against the size of the V-tip, so it actually didn't cut quite deep enough. So I had to do this a couple times. I was going to bring them with the and around the ones that failed, but I had to go to other bits. So there's the final product with that. There we go. That's what it looks like. It turned out quite well, I think. And then this is actually what it looks like when you snap stuff with it. So it has the one thing to know is if you make one of these, you have to flip the sign first. Otherwise, I did that. However, if you look right here, you can see there's no like little mark. This character is supposed to have two like little ticks that come down from it. On this one, you can see they're right there and right there. But when I generated the DXF, I forgot to select those in export. So be very careful. Make sure you have all these features. So this was a note that she sent me to add it. So it was successful. It worked out very well, and she really appreciated it. So then this is random, but these are just like the speeds and speeds I found that worked well for it. Apparently, you can run these tiny tips at like 10 inches per minute. So if you're ever going to do that kind of stuff, I guess you know that now. The specific little tiny mini CNC in there, it's like probably around 20,000 RPM. It doesn't actually say, so it's like 340 hertz. Yeah, that was my experience making a small little wax seal. And it worked out well. And thank you to Chris again, because as you saw on this slide here earlier, there was a lot of bothering Chris.
So I was going to say that I don't think the size of those letters represent the amount of bothering of Chris. Just judging purely from historical reference here.
Oh, no, it was like a block text email I sent him. I was like, hey, Chris, here's 10 different things I'm wondering about. He's like, you have a design? And I was like, no. So yeah, have a design, then find your joins in there. I guess it's a moral story. But I had a week to do it. So and Amazon has like 1 day shipping. So I guess if your wallet's deep enough, go for it, right? So
which machine did you use it?
I don't have a photo of it, but it's the tiny little like graving CNC for PCBs back in the shop. Yeah, the little one that has like a vacuum plate. But we just took the vacuum plate off, and then I used like what are those?
Yeah.
Strap clamps, yeah. I use those to bolt it down to the.
Oh, well, we strap clamp the chuck to the bed and then just set the center.
Yeah, I was gonna say I think that truck speed.
Oh yeah, that's
Oh yeah, that was pretty fun. I should have brought the one that failed along, but.
We also then we laser engrave one.
Yeah, there was a laser engrave on
Those
it.
didn't make the pictures. It seems so.
Yeah.
Did you
I was
buy?
gonna bring it.
Did you buy a blank? Do I see like a handle down in the chuck?
No, so you can unscrew the end, like on this one here. You can unscrew the end from it, but you can buy the blanks for $6.
Yeah. Okay.
I didn't make the blank. That would have been cool, but I didn't have time. So I was like, oh, I'll just do that.
That's it.
So when did you find out her birthday was?
I knew it was. I knew when it was. The problem was that it was shortly after school started, and I had started a job, so I was a bit busy, and I also didn't have the foresight to actually start. I was like, I didn't come up with this until like a week before. So it's all on me, really. I didn't think of it until like I was
Well,
like,
no, you can also blame your parents.
well, she was the one who told me, and I've known her since February of this year, so I did know. It was June 1st, and I had like a week or something to do it. Plenty of time, yeah.
How big is this thing? How?
Right, that big.
Like a quarter?
I should have brought it. I'm really regretting that.
It's small.
Yeah, it's very small. So that's the reason the tooling is so hard to get, or not hard to get, but so like I was like having a hard time being like, oh, what size do I need? It was like the choice between like a 1 millimeter like diameter on the end of the tool and a half millimeter. And I did not know like how big it was going to need to be to cut this out. I should have intuitively gone with the smaller one, but they were wood bits. I couldn't find any ones that were rated to metal. So these wood bits can apparently do 10 inches per minute in brass. Admitted they're very shallow, but like it worked out. So
And what was the issue using the fiber laser again?
you can see in this design here, there's this really like detailed little flower. This is the one I cut out on the fiber laser. It turns out that with wax, it just doesn't go into the holes very well.
Oh god, the fiber laser can make such tiny holes that like it just doesn't.
Yeah.
You have to design on how to scale the material.
Yeah,
So
the
just
fiber
had to
laser-
be a little bit deeper.
for a coarser, and that's why the CNC was there.
Yeah, yeah. So the fiber laser one left very, I don't know. It has a very sharp finish to it as well because it cuts straight down into it. I mean, you can do 3D, but I didn't figure out how to do that time, so it was kind of hard to do that. So
Sorry to interrupt. How was the built-in laser across the curves?
across the curve's really good. It's super clean. Yeah. It looked really crisp. The only problem was it just I didn't have this one. I also missed a feature. I think I missed like this right here. It's when I was exporting in SolidWorks, all the lines were gray and it's really hard to see where they were. So I was like, oh yeah, like all right. When ran, oh, you know.
So what was the program here of converting your image?
Converting it to a DXF. Yeah, so the person who did the artwork gave me an SVG file, and then to make it into a DXF, there's tools online, but what I had to get it to the right scale, what I wanted to do was pull it into something. So I used SolidWorks. You could probably use Fusion 360, but I turned it into a block in SolidWorks, then flipped the block, and then constrained it to a circle, which is the circle you see here.
That Adobe program you mentioned online.
No, I was just saying, like, if you want to do this and you have like a raster image, because raster images, they're just pixels, right? You can't tell a computer to go along the line on a raster image. So Adobe has a free tool online. If it's like a high contrast image, it's black and white, you can have it trace the outline and kind of go through it. But thankfully, the person who did this had expertise. So yeah.
Sean, Adobe Capture is what you're after. Yeah, I have it on my phone. I use it a lot. Inkscape will also do.
Inkscape for ProDraw.
Oh, I didn't realize Adobe Capture because it's just the one I use is just like an online. You just upload it. You have Adobe account.
Right, and they have an Android app that I use for like if I took a picture of you, then they have a lot more grayscale kind of capabilities to capture what I want. But like Inkscape is very black and white, so you have to have a really high contrast image in the Inkscape. But with the Adobe products, they've got a lot more kind of flexibility in there.
Yeah, the problem is I have a little bit too much access to software. So general, because I'm in university, so generally people and I don't have SolidWorks and stuff like that. I'm not entirely sure how you do it. I think with Fusion there's a function to export the stuff.
There's a lot of stuff.
Chris can surely tell you more about Fusion than I can. I don't know very much, but
Yeah,
yeah, Fusion's good. But yeah, that was any other questions for Alec? And Niamh just got here.
That's a really tall first birthday gift. What are you doing next?
Oh yeah. That's it didn't take too much.
It's got a lot of wow factor though.
I guess so. Yeah, she was very impressed with it. Her mom thought I bought it. I did that.
I've definitely done that before. Like, no, wait, hold on. I made that.
Yeah.
Pick that back up.
She just like, oh, he must be like lying. Oh.
Video.
Well, that was it.
All right, thanks.
Unfortunately, I don't have.
It's not that. All right, Dave's up. What do I do here? So you can share it here. Sharing here.
Oh, not on top of here, maybe here. Yeah, hard to share here. Oh, Cody, we on there. Weren't ready for two.
Here.
And do. I don't know. I was. Go, so that'll be up there. What? Yeah, I don't think it's the same.
Cool.
Go ahead.
Hey, good evening, everybody. My name is Dave. I'm kind of new, reasonably new to Sector. Can I still say that?
Sure.
Yeah, reasonably new. And I've been putzing around with some modifications to the sailboat that I built. And so I thought I'd share that with folks today. Is anybody here sailing at all? Oh, cool. All right. So yeah, just a little bit of history then on this. This started actually with a painting. My father and I were at a wedding, and I just moved back to Wisconsin. We've been away for a long time. And we used to sail when we were kids, or when I was a kid, and found ourselves looking at this painting at a wedding and thought to ourselves, I wonder if we could design and build a sailboat. It wasn't totally crazy because in grad school I took a nautical design class that resulted in a model. So I'll pass this around. And although this is completely different than the sailboat that's I don't know if you noticed out there, that's right, and it's not much explaining it.
Dave's sailboat is parked up your Wi-Fi, man.
Pardon me?
I said Dave's sailboat is parked up.
Yeah, it's a sailboat that's no front. But really more than anything was just an opportunity to spend time with my dad building something. And that was the most magical and precious thing about it. A lot of people ask me, I'm proud of the boat, the boat sails really well. For me, the most spectacular thing was just spending time with my dad, which was a lot of fun. And so tried to read up on how to design a boat. I'm pretty much self-taught in general. There's a really good boat if you ever want to do that. Principles of Yacht Design, which goes through a lot of, I'm an engineer, goes through a lot of the engineering behind how to build a sailboat. And one of the things I really love about sailboats is a blend of aesthetics and also function. So there's a lot of decisions you make in what the boat looks like that you either like what the boat looks like or don't like what a boat looks like, and then that pertains to how the boat functions as well, which I thought was pretty neat. I also joined the Wooden Boat Forum, which was a spectacular resource, although I kept emailing all these questions like, what should I do in this situation? And universally, the response would come back is, what are you screwing around with this? Ask the designer what the designer intended, which was really hard because I was the guy designing the boat, and I confess I had no idea what I was doing in a lot of situations. But you could start through the abuse. There were generally pretty good people in there, so it's kind of fun. Designed the boat in CAD. This is back in the days when I was running Pro E. I've switched over mostly to, well, I've switched over SolidWorks and then to Onshape lately. This late stuff was done to Onshape. And then that's my dad. We built that boat that's sitting out there over a period of time. Took a long time. It was a lot of fun, made a lot of mistakes, learned a lot of things. Built it in way too small a garage, which was really horribly painful. That's our version of a CNC lathe, because we didn't have a CNC lathe at the time. So that's a NACA foil for the keel, or for the part that holds the boat upright. And we've just done it in an Excel spreadsheet. We're spinning that around and driving the thing around manually. It's kind of insane at the time. And then I pounded up a pattern, and we went to every tire shop in town and stole tire weights for like the better part of half a year, and melted our own keel for the bottom of the boat. And there it is launched. So it's super fun. A couple things that made this, and that's my wife. There's my wife this weekend. So we still sail a lot of fun out of the boat. It's pretty fun. A couple things that made this sort of unique for me. I wanted, because once again, you make a lot of decisions. One of the most common questions is why there are two holes in the back of the boat, and it's because I picked what's called a self-draining cockpit. That's, in theory, was above the water line. So when the water goes in the boat, it just drains out the back. I can tell you when I launched the boat, there was a lot of heart palpitations about wondering whether or not the water line was going to be above those holes and the boat was just going to fill with water. But lo and behold, the CAD worked out, and it worked out really well. So that was one of the design decisions I made that had some ramifications with what I wanted to show real quickly in a couple minutes. This is the other thing, a couple things that I wanted to do that I think were a little bit unique about the boat. I wanted a huge cockpit. And so the mast is actually stuck out on a little island that's in the middle of the cockpit, which allows you to kind of have more room, with more people on it. And then one of the things that really ended up cascading a lot of decisions, I wanted a flat floor, but a raisable and lowerable keel. So didn't want to have to fight to keep the boat upright. And the way you do that is you put a big chunk of lead down on the bottom. But that's not very convenient for trailering the boat. And so generally people have swing keels that pivot up, but they leave like a big divider in the middle of the cockpit. And I wanted to be a little bit more social. So I wanted a flat floor. So I came up with this, my father and I came up with this, oops, that's not my keyboard. This sort of lifting system. Let's see if this video goes at all. Maybe you can kind of see it there. So there's a little crane thing that folds flat on the floor, and then you can lift the keel up. There's about 350 pounds of lead there that's going to come up from the bottom. And this is how you get the boat on the trailer. It's a wood boat. I don't want to keep it in the water, so it's a trailer. And it comes up quite a bit. It's got a 39-inch keel on it, which is quite a bit of lift. And so it comes up really high. And one thing I kind of figured out, but didn't really quite understand, there's a picture of it up and on the trailer in the way. And so what that drove me here to Sector on is the problem is raising the mast. The mast is getting heavier over time. That must be the case. It can't be that I'm getting older, not as strong as I used to be, because it's getting really, really hard to raise the mast. And typically what you do is you just stand back here in the back and you kind of walk the mast up. It's right there. It's maybe weighs like 75 pounds, but you walk it back up. But I got that big keel thing that I raised, which is preventing me from doing that. So you have to kick it off to the side at about a 30-degree angle and kind of stand right in there. And literally I was on the verge of not being able to do it anymore. So I spent some time brainstorming. How can I get the keel up automatically? Talked to Chris, got some advice from him, different aspects. And there were two ideas that I had. One is I could pull it up from this side, or I could push it up from underneath, which is the way I ended up kind of doing it. And I ended up doing that with this little linear actuator. People have never used linear actuators. They're not very much money, $80. And it basically is just a lead screw here. That's my eyes.
Those might work.
Felt like that. Yeah, so if you push on this screw will screw out of here, and it will raise about 6,000 newtons and about 450 millimeters of stroke. So this is what I had to work with to try to figure out like how I could work that in here. I think Chris thought kind of similar themes, bugged Chris a lot, and thought that was not a bad idea. So I kind of laid out where I would put that, how it would go, and what would entail. One of the cool things that I used, if you've not used a program like this, if you're mechanically inclined, there's a pretty cool, fairly inexpensive kinematic synthesis program called SAM. I don't know what SAM stands for. It's from the Netherlands. And it basically allows you to build simple stick models. So even though you can't, this is the mast, and there, that blue line is the actuator right there. And then as you raise it, lower it, you can apply forces to it, figure out what the reacting loads are to this sort of thing. And so this convinced me that the biggest load I would see was about 3,100 newtons. So in theory, my screw is going to be strong enough. And I could figure out kind of what the reactive forces were and try to make an assessment as to whether or not the boat was going to be strong enough to deal with that. So SAM is a pretty cool program, and I enjoyed using that as well. So here's the design that I came up with. One of the things that I'm kind of ridiculously proud of, that I probably shouldn't be as proud of, is this little pole here on the side, which is named the Vicky. And Vicky's my wife's name, because that was the role that she historically played in raising and lowering this mast, was that she had to kind of stand out there and hold this heavy mast up while I was trying to lift it. And so I needed to drop the mast down right about there. And looking around, I realized that there was this tiny little window here that I could fold this kickstand down, and it would go in between the tire and the boat itself and clear literally by about ½ an inch on either side. So that's where kind of the tools here at Sector came in. It ended up involving this kind of really wonky bracket down here, which has a pin that's set at a couple of different angles. And using CAD, I was able to determine how I would get that so that it would swing down and drop exactly in between the boat and the wheel and still hold up the main device. And so I was, there's the bracket that I think the way we work this is, as opposed to trying to bend the bracket up, Chris suggested I basically just cut this up into individual pieces and weld it together with a little bit of a fixture. Use the plasma cutter, which worked spectacularly. And so this thing dropped in. Do I have a video here? I think I might have a video. This isn't the world's best video. Yeah, of all the things, I'm kind of a little bit more proud of this than I probably should be. The fact that those work, oh gosh, it's kind of choppy. But you can kind of see a little bit, it drops right in between there, and then ends up with those rollers exactly where I wanted them. So you can put the mast on and raise it forward. It worked pretty well.
I'm just more impressed that the fender and the cab was in the spot. That seems,
Yeah.
that seems the hardest.
So here's we're all about time-lapse videos today, I guess. This is a time-lapse video. Boy, this is really super chappy. There, I the kickstand or the fixie's out of the way. You can roll the mast back and then clip it in down at the bottom. And then the actuator, which I just take out of the boat when I'm sailing, but drop it down in place. And it swings right up.
What's your time to, it's like horizontal curve?
It takes about a minute and a half to glide. It's not fast. Yeah, but it's a lot easier than it used to be.
Does that actuator get you like 70% of the way there, outside the weight, or is it?
87 degrees, if I recall correctly. No, because I wanted it up far enough so it was still leaning back. Like I didn't want it going forward, but it's close enough so that I can push it up and push it off the actuator. It's a little nest, but that actuator, a couple of prongs that sort of stick into a nest on the fence. And that was took a kind of an obscene amount of time to figure out where the actuators go for the most mechanical advantage I could get, but still to get it up far enough so that it could show.
How did you get the actuator?
You know, that was, it's funny that you mentioned that. Of all the things I could not check, there were two things that I could not look at or could not analyze. One was the actuator sitting right there is going to punch a hole in the bottom, but I've got it positioned over all the reinforcement for the keel, and that's pretty beefy down there. Is the keel is withstanding really all the force of sailing, which is fairly hard. The one thing that was a total guess to me is this device, that hinge right there, is called a tabernacle, and it's designed to be able to withstand large vertical loads because as the boat is heeling over and the wind is pushing on that, you have a downward component of force. But when you're raising the mast, there's an upward force on that, and it's about 700 pounds. And I couldn't recall for the life of me how I had screwed the tabernacle in there. Apparently it's strong enough because it is not ripped out yet.
When you were thinking through the different ways to do this, you had to have considered just a winch with a pole?
I did, yeah. So if you go out and take a look at the mast, there used to be, there's like a place you could fit a pole that goes up. And the problem was that because you can't pull it straight in line with the boat, it's got to be off a 45-degree angle. I was going to have to find a way to mount a winch kind of out in the middle of nowhere, so it didn't, end up the line didn't end up hitting the boat. That would have been a very valid approach. And I guess I'd never fussed around. I hadn't used the linear actuator before, see more fun. Whereas I used a winch to raise the board of the keel, so I already had one of those in play. But I think I made the right decision because I would have had to find some way to hold something out here, kind of in the middle of space here. The whole problem continues to be that you can't pull it straight forward. And I think I had to solve this problem that a lot of people are just push the mast up. It was because of the design decisions I made that up with a little bit harder.
When did this whole thing start? Because some of those pictures look kind of old.
Yeah. Let's see. Here's an important life tip. Don't ever start a project based on someone's wedding. Because every year they have an anniversary. It's like, oh God, we've been working on it another year. We started that boat, I want to say like 15 years ago. And it took 7 years to build. But my dad lived in Milwaukee. He's since retired, and my dad is since retired, and I guess I retired too. I'm getting used to saying that. And so he'd come once a week, and we'd solve the world's problems and make a little progress in the boat. But we weren't really cruising on getting it done.
So because you leave the actuator all the way to the facility, you don't have to worry about the weight or anything like that.
That's correct. Well, the battery lives on board because raising, lowering, and keel uses the same battery. That winch train arrangement stays on board all the time. So, and weight isn't that much of a factor on this boat. I mean, it's not. We specifically didn't design a racing boat. That 350-pound keel keeps this thing really nicely up. I've never flipped the boat, and I've tried to get it over, but it actually, as the boat keels over, it gets to a certain point that it spills a lot of the wind out of the sail just because it's tipped over so far, and then it'll self-right itself. So it came in within 50 pounds of my design target, and I'm pretty pleased with sort of where it sits.
And you use the actuator to drop the mast also?
Yeah. Same exact process in reverse. You just kind of, unloose the sail in the front. It's called jib. Basically, drop it back into a nest and then lower it. And it has worked. We've been out half a dozen times, but it's worked. It's very cool.
Does the actuator just sit on the ground, or how does it make it catch?
That's another interesting, yes, it just sits on the ground, because I want to make it super easy to set up. But I ran through the problems there, through the analysis, and the actuator is not straight up and down, it's at a kind of an angle when it flanges. And according to my map, the actuator is being skid out from underneath, and I chose to not believe that, and the map was right. So there is a couple of holes here, and I actually just wrap a strap around the base of that mast and tie it in, just hold it. Like that.
I was gonna say, I was trying to imagine how the metal played with this.
It does slide, yes, as the map predicted it would, and as I chose to form.
Is there a solid connection that can point where the actor?
There is not a solid, there's like a nest, if you can see, there's a couple of, and once again, it's just, I think we did these in the CNC lathe. Yeah, so there's a couple of like posts here, and it's sockets over like a yoke that's on the mast, it's just operated in the mast. And actually, that's, we have to weld up that crazy bend fixture for that yoke, which is super fun. So it just kind of sockets in, comes on gravity, pull it out.
Gotcha, so it can't slide off. So
In theory,
So those linear actuators are really sensitive to like a bending moment. It's like basically they'll like totally bend in half. It's like a hydraulics or pneumatics where they don't want to have an precise linear force. So
Spin with the check, you ever bought down your actuator and got it stuff?
I have never done that. No, this I don't have a spare for this, so this is I bought it from eBay. What am I in love with? What am I due for? Is it gonna fail on me?
No. It has to done it. Yeah, usually they got.
Pardon me?
Oh, I say usually they got limits with it's built into them.
Yeah, they are, and this thing, yeah, it'll run to a certain extent, and then it just stops. So, and I'm assuming this was the longest, strongest one I could find. And it's slow, but it seems to have got it. And I think the 2 months.
any other questions?
I just want to thanks to Chris for plugging in multiple times. It came out really well, and thanks to the sector for learning a lot of stuff.
Yeah, so to run down, so use the CNC plasma cutter, the lathe,
Seems to lay out.
the middle, down,
And manual belt.
and the welder.
Yeah.
So lots of things going to make you simple things.
Super fun. Thank you, buddy. I really enjoyed it. Thanks for welcoming. And if anybody wants to, the model boat floating around here, that's a marble, it's called a marble head in the 30s and 40s, before the advent of FRC. There were lots of boat clubs where people would build model sailboats in the winter and then sail in the summer. I would love to get some people. There's some great places to race model boats here, and with the laser cutter here, that is a picture-perfect laser cutter project. That was entirely laser cut except for the planking on the outside, which was all done manually. You could even have done that if you were clever. Basically, cut that out and assemble it like one of those little model airplane kits we used to get for kids at those somewhere.
Where do you recommend model racing?
Well, I have no idea here in Madison. That's the thing is I was in San Francisco at the time, and at Golden Gate Park in San Francisco, there's a pretty big club that does model sailboat racing. The same thing in Central Park. In New York, there's another pond that people. So it'd be fun to get some people and get one of those together. We get all the tools to do that. It'd be pretty fun.
Yeah, I agree.
So we're doing the block that is over by the block, over on the business.
Yeah,
and be a nice good spot because it's kind of circuitous, so you can lay out and have some good turns.
Are you talking about Freeman Beach?
Oh,
Penny Park, the little pond.
Oh, yeah, no, you're right. Yeah, that's pretty big.
Yeah. So if anybody wanted to, there used to be pretty in the 30s and 40s. They took a graduate class in in sailboat design, and that guy was a fan of model sailboats. And he had this huge collection. But in the 30s and 40s, it was kind of a big deal. So people used to really compete. It'd be a lot of fun to do that. So if anybody wants to get into that, I'd love to give that a shot.
The doping scandal, the little jet boat.
Yeah. Yeah.
Thanks, dude.
Thank you very much. Really good.
As far as I know, Don and Niamh are our last presenters.
I have a new thing I want to show off.
Oh, now Davie's all.
You're missing an asterisk, 45 the price and twice the time. Get your copy.
Hello, I'm Niamh.
I'll show the screen.
Oh my
See,
goodness.
told you.
You fail.
Yep, not good. All right, promise you.
I'm Niamh. I'm Sean's daughter. I've been in and out of sector since it was at its old location since I was in high school. I'm very lucky I get to bother Chris also when I have silly little questions. And so I decided that I have too many books and realized that I needed something larger to hold all of them. And so I kind of was looking around online, and as like a thrifty person who just graduated college, I don't want to drop a bunch of money. My dad always has wood lying around, so we kind of went from there. These are the beams from my dad's garage that he tore down and has since rebuilt, but it's some really unique and beautiful wood. So we kind of spent, I don't know, a couple hours the first night pulling rusty nails, couple screws. That was a fun time, but we used the bad planer here so we wouldn't risk ruining the nice one. But it just like, it immediately was like very, very beautiful and cool to sort of reveal the surface there. Then kind of like, I did some drawings mocked up based on something I found online. But I wanted to preserve and use as much of this wood kind of as possible. So it grew larger and larger to use as much as we could. This is like our first kind of test, seeing what a shelf might look like, gluing up what I think we ended up borrowing quite a few different clamps from Sector. We were in and out between here and my dad's home shop. But it's always good to have tools and friends. This was one of my favorite parts. I learned how to mortise and tenon. So that was what I used to joint the legs together. I wanted kind of an arch that didn't happen, but I wanted legs that in the back were straight up and down and the front kind of angled. And so my dad was like, all right, try it by hand. So we set up sort of a jig. There were a lot of jigs in this process for the little saw. And I learned to do it by hand, and then I also used some other saws and tools. But definitely with wood, it's sort of the like less is more. You can take off a lot. And some of my pieces were not great, but they did the job. Had a fun time.
Well,
with it.
so yeah, the first picture was, you know, I wanted her to learn how to do it by hand. And after, you know, a couple hours later, they still know how to do it with chop saw. So one of the sides of the bookcase was more traditional by hand, you know, a tenon saw with the extra guide for depth. And the other one was the chop saw, which is the next photo. See, it's not as clean, but it's certainly better.
Just use a chisel, clean it up. It was so satisfying though, because it was much, much faster. It's very, very good. Then we came back to Sector and we decided in the leg to test, like creating the holes, making sure that like there was so much testing in this project. And I kind of like also decided that the mortise and tenons would kind of just work out, and they did. We had some shim, some glue. It all ended up being really solid. This is us filling the glue. And here are the legs. When we first put them together, we did have to cut them still to final length, but I was really satisfied because they did, in fact, fit how they're supposed to fit. Just took many hours with a little chisel to get it
I
to
can
work.
interject, this is a super important lesson, which is do not cut your damn wood to the size you want it. Wait until the whole thing's filled and then cut it to the size you want it.
Yes.
Which I feel like it's learned around here a lot of times.
Well, and
Yes.
even more important than that is, as you can see the final photos, the tops of those, the vertical parts of the legs, where we call them stretchers, the part that has the tenon, that in order to cut those with the same angle, like so much woodworking, the less you measure, the more accurate you are. So we have no idea what those angles are, but when we put them on the sled, on the table saw, and when you cross cut it, they all automatically reference a perpendicular cut to the back of the vertical. So it was sort of irrelevant, other than the fact that we knew that we wanted the legs flat on the bottom and the top flat, and by flat I mean perpendicular to that.
The other part of this project, using reclaimed wood, involved a lot of wood glue, a lot of tape on 3, and sawdust. So we collected, after lots of sanding, various kind of bags. We tried to color match, but I just ended up making a paste and filling in. So this is like, kind of, you can see some nail holes. Every piece of wood had a lot of holes, but my dad's like favorite saying is like, the wood tells a story. It's all part of the story of the wood. It doesn't have to be perfect. So the goal was just to kind of like make an even surface. And that's what we did, but it took a long time filling, sometimes refilling if the glue shrunk as it dried, and then sanding again. I did so much sanding, but I have a good relationship now with the festival. This is more hole filling. A lot of late nights in the. Oh yeah, I used some used sandpaper. So because part of it was like I didn't want to get it all over the piece that I'd already started sanding. So that helped to kind of mitigate the spill.
Yeah, so we cut slots in that piece of 6-inch triangular paper to provide a surface to wipe the putty through, because a lot of what she was filling wasn't just the nail hole or screw hole. Because we were using reclaimed wood, you would catch the side of a hole. So that's what you get this long sliver.
Yeah, there are a couple of knots that I also filled, so it's definitely not perfect, but it works. It's a little Chris cameo. My dad, we used a shopping cart that was around. That's very helpful to transport all the wood we were taking in and out. Here are all the boards finally like planed down, final width. More kind of just mocking up the shelves. Each shelf is like has a different depth. I kind of wanted that sort of like step out aesthetic. Here we are figuring out kind of putting the legs together, the stretchers, the holes, everything set to go. I decided kind of partway through to put a backer on the shelf so that my books would have something to run into. That was another addition, but we found more wood. There's always something lying around to use. There was also, here's yet another jig that we made so that we could drill holes in each shelf and 2 places, actually 4 places for each shelf, so that there are pegs that are fit into the legs and each shelf fits onto those pegs. But it was kind of a process laying out like exactly where each of those holes needed to be placed on those backers and then on the edges of the shelves. So this was also to help like how deep does it need to be? Where does the placement need to go? All of that layout just takes a long time, but I learned was very useful so that I had shelves that fit on the legs that I built. Here's more laying out things. Here's some little sort of pieces that I was sanding down to fit. Have a drill belt sander in the metal shop. Works well.
Yeah, you just tamper the end of the 3-inch bolt with pins. And it was turned out to be a very fast way to tamper the bolts and throw the drill. She was spinning the drill as the belt sander was spinning.
Yeah.
Much safer and forgiving about 4 years. We started with vice grips. Of course, we realized that we could start throwing things.
Yeah. No, this is fantastic. It went quick. Here's us fitting those little dowels. These are kind of like they're stretchers that go horizontally between the legs, making sure those are fit.
Those dowels that hold those horizontal stretchers, we ended up just using the extra 1/4-inch steel we had and made our own instead of using wood dowels and just steel. This project evolved and got lighter and thinner, so all the connections became more important. As you see the more important.
And the legs, they got thinner and thinner because it was sanding. It was like almost midnight, and I kept taking more off the legs. But we made it work.
More design.
it was also that it tapered. So there's like one of our first fit tests to see if everything's sort of gonna hold before we start putting the shelves on. Here are those bolts in. This is gluing in the bolts into the legs, making sure that we didn't glue kind of the wrong place, because we had them set with the shelves and didn't want things to get stuck, but also we want them to be straight.
So this, what we ended up doing is, it evolved from, this whole project was, let's get one phase done and then figure out what to do next. Which is not necessarily the best way to design, but it ended up working out. But the original intention here was to use those cam locks that Kia furniture plays with. We use it, and it's like a 1/4 inch dowel with a little eccentric cam to twist and turn. So I found the source of those, bought some, tested the first one, it worked, and we got to actually, okay, let's really test and make sure it works. I started snapping. Didn't give me confidence that they were going to hold. And how thin, I mean, for reference, these legs are about 1 inch at the bottom, they taper 2 inches. And the shells themselves are only 1 inch. So the amount of material, if this was all steel, it'd be a problem. Since we're using 100-year-old duck fir and hemlock. The hemlock actually is more problematic, but duck fir is semi-hard. We didn't have confidence that we were going to be able to build something that wouldn't fall apart. And of course, being your dad, I was like, we're not spending a month and a half on this thing and then realizing things are going to fall apart. So it evolved to this idea, which is basically those are 3/8 machine bolts, so we cut the ends off, and then use brass inserts. But these are heat applied brass inserts, which means that they're designed for plastic. So again, I didn't want to use. I was worried about when you get to a 3/8 brass insert, they're about almost a 0.5 outside diameter, which means that if we were to, even if oversize the hole, there's risk of cracking this wood. So we end up, just marine epoxy them into these holes to keep them locked in. That provided a positive connection between the machine bolt and the leg, which then allowed us to insert that into the shell. But there was definitely a moment of concern that we're going to be able to lay all this out because we had to put it all together at once. So we're trying to get there, but that's kind of what you're seeing here is the process of setting those brass inserts on those wood shims, which are acting as parallel guides, perpendicular guides, so that when we set those brass inserts, epoxy, they're perfectly perpendicular with the bolts, because those bolts screw in well.
So those bolts are not glued to the brass insert right here?
Those threaded in place.
Did you fill the holes completely with epoxy and then apply heat to the brass inserts?
No, so we're like I said, making up as we go, using the heat, the style. So the style, I don't have a close up there, but the style of those brass inserts are more tapered bent, so they don't have a screw. They're designed for you to keep them up with the force and press them into a slightly undersized hole. So we slightly oversized their hole, used epoxy, set the brass. But all again, so we didn't want to have any kind of lateral force.
Could I ask how you align the holes on the legs with the shell? You did those separately? Not drilled through at the same time?
So yes, very good question. So we ended up, what did we do first? We ended up.
We had little markers that we put in the holes on the shelves to
That's
mark the legs.
Okay, yeah, so you didn't measure, I guess,
Go back a
before you
couple.
did
This
I feel like I put it in somewhere.
so that's
No,
this
I
one.
think-
So what you see.
Really got this, but.
So well, that's a, yeah. Go back.
I don't think we have one
It's the modified bolt.
back there.
That one. So that jig, so if you ever use the dowel jig, which is what you see in the bottom part of that jig, it's a dowel jig clamped to that plywood amalgamation. Because the dowel jig wouldn't allow us to catch the side of this hole here.
Yeah,
So a regular dowel jig, no problem, you can center drill a hole.
that's what we did for
This
this.
one, because this was glued up already, so we slowly drill that hole. We had to make that in order to offset it enough. So basically,
Yeah.
this is providing the centering, and that's providing the engagement into the side of the shelf. So we drilled all of these first, and you can see we carried that center line down to the bottom of the shelf. So then when we went and set those onto the verticals, we were able to accurately transfer that hole over to the vertical using the dowel center. So basically a 3/8 dowel that has like a cone on it.
Gotcha.
So then we were able to carefully press that into the leg, transfer that hole exactly, and then take that and drill the same jig into the side of it. So it was very much like one shelf at a time, do the whole side. So that was.
Well, that's why we had all this tape here to mark. Like I spent time marking out so we knew where to set down the shelf. I'm not sure. And yes. And here's testing that, making sure like we had dowels in, would the shelf go on? Indeed it did. Here they all are. Blue. And then here are all, this was like the real moment of truth. When we put all of one side on, we were like then pretty confident that we could get the other set of legs on. And so it was very, very satisfying knowing that it would go together. Then this is our first like mock-up, seeing it standing upright, put a little foam down.
So that, yeah, the photo on the left is, there's no, the two legs are glued with part of the tenon, but that's just pressured in together, right? So we'll get to the,
So
quickly how it's actually keeping it from falling apart, but right now, this gravity.
there definitely was, our concern at this point was the play kind of side to side, but decided to get some finish on first.
So that's just a oil wax finish, not one of the finishes before you did the final assembly.
And then this is the final assembly. We brought it over to my apartment and got it all put together again. Everything still fit. Then this was the fun part, where on the back of every shelf, we didn't mark this beforehand. We decided to sort of mark it then and have some faith. But I took this tool, I drilled through the wood and into each dowel on 4 of the back.
Yeah. So that's a 1/4 20 half. So we drill a hole through the back of the shelf, engaged in the center of that creates, but you have a careful layout, which allowed us to put machine bolts through the back of the shelf into that creates drive. So creates cut out creates bolt screwed into the leg, and now that's screwed into the shelf. So that now the entire thing is not only deconstructible, but it's solid.
I'm super sorry to interrupt, but that's truly safe red bag. On red bag, that's actually blocked on the bag.
Oh, I'm sorry.
And so there was very much like some hesitation and nerves, but once I hit the metal, screw in, screw out, and repeat until we did all of them.
Yeah, so we had to do that at final assembly because we wanted to tap it through the wood, so she's not. We knew where to hit it. We're drilling it. We're literally tapping through that 1/4 inch shell before it hit the metal. So it was definitely an interesting moment to pull the tap out. It's coming out of the chunk of wood and seeing metal.
Yeah.
But you didn't, because we're above the platform on the bottom of the shelf, but you didn't poke all the way through.
Correct. Yeah. So there's one pin here, holding that, and we did that so that we could have access to this on the backside of the shelf. The other pin is here, and we decided we didn't need to. We could always go back and do it, but we decided that just locking the back there was tough. Because everything's out, so tight sometimes. But in theory, we could go and drill a whole bottom tap that, but just 10 machine bolts is back.
Oh, yeah, and then well, I guess the tape answers the question I was asking, which is like the depth of your thread. And I realized now that you stopped.
I might have drilled one of the tap holes through. We didn't tap through. Yeah. But it's character. There's a bunch of holes. Another hole.
Here's my cat testing it out. Decided it was approved. And then here it is in place. And so far there's been a little bit of splaying, like a millimeter or two maybe at the bottom, but so far it's holding. The books are on, and it's good until the next time I have to move it, probably, unless anything changes or gets hit really hard. So.
And it's amazingly rigid in it. You would expect that that shape to have some recognition. And I wouldn't want it on a boat or back to the truck moving around, but in its stationary position, it's pretty solid, especially when the mat is moving.
You guys did all the load counts and like Fusion 260, right?
Oh, yeah.
That's what
It's not a base fancy actor program.
It's really beautiful.
Thank
Very
you,
thoughtful,
yeah.
Really, very bright.
Yeah, I'm very, very happy with how it turned out.
But the same thing, it was really fun.
Yeah.
Although I honestly think the thing I'm proud of most is that Tris was confident that my retrofit last minute 3/8 bolt the brass chain actually was going to fully fail.
What's your retrofit?
Oh, that, yeah,
Like
like,
a 4-level deep.
oh, sure. So far we've proven wrong. It's not hard to do, which is hard to do.
The IKEA transition to random bolt hardware and a lot of epoxy with them.
The shelves themselves, are those biscuit jointed all, or is it just?
Python 3.
It's Python and that's sufficient to hold up, that's really cool.
Yeah. If it breaks, it's probably going to break somewhere other than glue joint. Like glue is really stronger than glue.
So you explained all the pieces.
Correct. Yeah. So we planed everything down. Although, did we run through the planer after? We may have one pass after we. Yeah. So after we glued it up, there was one buzz.
Yeah.
You have any trouble with the cupping? Or
No, I mean, so these were. So I've been saying most of it was a mixture of duckfur and hemlock, so very different density species, but they were fairly, clearly bone dry, and we didn't even join them. We just ran them through the tabletop, flipped them over, ran them again, and then flipped them the third time to a straight line with edge, and that was sufficient enough. The company usually happens to have it dry, usually dry like 95 years ago. Sure. And these were 2x4s planed down to 1 inch. So we definitely had the ability to take off 1/4 inch.
I don't know anything about hemlock at all. I've never, what's hemlock like?
It's soft. It's softer than pine, honestly. I mean, it's got a very, it's very, I wouldn't call it balsa wood, but you can imagine playing with balsa wood. Which is then, part of it is like, this is wood saved from building we took down. The duck fur is just, the reason the duck fur is so valuable is that you really can't buy that anymore. But not nearly as clear. And old growth duck fur has just got a warmth to it that's really nice. And so that was the thing that kind of made me nervous. Right, to tell you about it, is that one of the legs in the back is hemlock. And of the structural components here, the legs are obviously important. So that was also the need to really make that strong connection between the shell.
How much you gonna start selling?
Oh my god. I think we started in like June and very casually worked on it, like here and there. Finished it mid-August.
So like $8,000 each.
Yeah, definitely.
Any other questions for anybody?
Nice, really beautiful. Looks very striking.
Thank you. Very excited.
Thank
Thanks
you
for
guys.
having us.
Davie, how about that?
I actually don't need it. So I'm gonna give you a sales pitch for a product I have no interest in. Cause I got this, and this is the right community for this, and I just wanna show it off. So my buddy sent me from all the way around the world, sent me an email about this gadget, and I just think that you guys would be the most excited to see it of all the people I know. And so ultimately, this stemmed from me being at my buddy's house and working on this boat. We were dicking around with the boat battery, trying to figure out if it had juice, and so I took my $2 Harbor Freight voltmeter out that I keep in the car out. He took his voltmeter that was like, his dad's analog one from the 40s or something. Neither one of them would give us the same reading, so he had to leave to his buddy's house to get a different voltmeter. And as an electrical engineer, I was, honestly, I was offended about myself. So a few minutes later, my buddy sends me an email unrelated about the Volti, which is a voltmeter that goes in a Leatherman like bit holder. And so there's a DC and a all around version. I accidentally bought the cheap version, went back and then bought the good one. The good one handles AC and temperature and a bunch of other stuff. But the DC version handles like, what is it, 2.5 to 30 volts DC. And so all you do is you pull this thing out and it's hooked to your voltmeter, and it gives you LED beeps or blinks. If I put it probably the right polarity, which is the right there now. See if it works in front of the audience. So it boots up, and then it's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 9.4 volts. There it is. It's just the coolest thing I see. So this one over here, when you boot this one up, it's got a lot more options. And so like it's got a little on-off switch. They both have onboard batteries. You only have to charge every now and again. We're talking about like $25 and $45. But I don't actually have a Leatherman that this fits in, but it's supposed to fit into the little like Leatherman screwdriver. Anyway, I'm just super nerdy geeked out about this thing, and I got the new one in the mail like literally on the way here. Just want to show you guys.
What's the percentage of error? I mean, 9.4 is high.
Well, let's find out. There's like 100 voltmeters here. Let's figure it out.
Yeah, maybe, yeah.
Yeah, this is a brand new one. I didn't pull it out of the smoke detector on my way out the door. I'll give it another shot.
They say if you ever have more than 1 voltmeter, you never know what this voltage is.
Yeah, it's the same with air pressure gauges.
The signal on
How long before you? Oh, there you go. Yeah, so that one's got the bit deal in it.
Yeah, actually, I bought that, and then I promptly forgot where it's so small.
I've never actually.
That was my question, was how long before you use it?
If you put it in a space, it's got a safety, Davie, so you won't stab yourself.
Yeah. Oh yeah, so he's got.
Is to put it in the bed corner.
Yeah, so this thing slides in here, and it came actually with instructions to file it down for just snugly fits yours. And so then this way, I've got a 2-prong kind of voltmeter situation.
That sounds like a manufacturer. They screwed up the manufacturer. Like, oh wait, let's just change one line on the instructions.
Yeah. Anyway, I was just super excited. I thought you guys might be as well. And this one doesn't articulate enough to get on the
When you use it with the leather?
No. Yeah, and so like, trying to figure out that.
Makes contact, nose of the pliers, into the bed.
How do I hold this halfway?
You need
that
your
one.
PhD in mechanical engineering. There's a lot of
Yeah, right.
stuff there.
All right, let's give it a shot.
It's like your finger first.
There you go. It works. Anyway, that was my geeky thing for the day. I just.
The other one has.
I grew up, we just put it on our little brother's.
This one does, yeah, so the $25 variant just does DC voltage, and then the $50 variant does 1 to 30 volts DC, 5 to 24 volts AC, and temperature, continuity, EMF testing. You can get into your spark plug, see if it's sparking.
Like an object.
Yeah, you get it like near it, and then there was also one that I found was like in their instruction manual. They said into like a beta testing or whatever, but you hold this in your hand and touch it to ground on a 12-volt system, and then you can touch your finger to like the fuse the seats. It was is 12-volt present or not. But it's this one, the fancy one is actually pretty cool because like when we were sitting outside when I first got it, I turned it on and it's at 92 degrees. But they actually have built-in calibration. So if you flip the switch, you turn it on, you turn off a certain, blinky light thing, I can calibrate the temperature by 1 degree.
I feel like this is one of those things you're gonna have the Leatherman. You have the tool. You're gonna pull it out to like, I got this, and then you're gonna forget how to use it.
Well, so that's why I'm keeping the simple one. The simple one goes in the car for that. The fancy one goes in the garage.
So is it that you don't make 120 volt version, or you're just not patient enough?
I think it's a secure safety concern. You get 10s, 1s, and so like that one gives you a green orange, and then a red for 10s, 1s, and 0.1. And so, like this is the, I get
high voltage is about.
Well, yeah, they specifically rated it first, so.
See if there is this right now, you really want.
Oh, yeah, here you go. As you can tell, I'm wildly excited, so if anybody has any more detailed questions.
Anybody else got anything else? There's a block party on Saturday out here. We've got, I think, 6 bands lined up, so there'll be food and beer and entertainment out here on the Southport Street. So I got the street permit, so we can block the street for the afternoon to be entertaining. So yeah, anyway, open anybody wants to swing on by, feel free. I'm gonna kill the Zoom, then we can go around and see who you are or what you do or what you're interested in.